Hey everyone, welcome back to the channel. Today in this video, we are going to solve one of the classical LeetCode problem 217 contains duplicate using Rust. We will break it down step by step and see how to check efficiently if an array contains any duplicate. So let's dive right in. So let us try to solve LeetCode problem 217 contains duplicate. So we are given an array of integer norms and we have to return true if any of the value appears at least twice in the array. That means if any of the value appear 2 or more than 2 times in an array, we will just return true. And if all the value are distinct, we will just return false. In the example 1, we are given an array of integer norms where we can see the value 1 appears twice in the array. So we will just return true. And in example 2, all the value are distinct, so we will just return false. So let us first try to solve this problem using our brute force approach. In this method, we will simply compare each element with every other element in the array. If we find any two elements that are same, that means a duplicate exists. However, since we have to perform this comparison for each element in the array, that means we have to compare one with the rest of the element in the array, and then again we have to do the same for 3, 5, and 3. The time complexity of this approach becomes big O of n square, which is not efficient for large arrays. So while this approach works, it's not optimal. Next, we will try to look at a much better and a faster way to solve this problem using a HashSet. So let us try to solve this problem using a HashSet. A HashSet is a unique data structure that only stores distinct values, which means duplicates are not allowed in HashSet. So we will iterate through the array, and for each number, we will check whether that number is already exists in the HashSet or not. If it is already present in the HashSet, that means we have found a duplicate and we immediately return true. And if it doesn't, we will add that number to the HashSet and continue checking for other numbers in the array. So let us try to solve this problem using HashSet. We will start with 1 and we will check whether that 1 is present in the HashSet or not. We can see that 1 is not present in the HashSet, so we will simply add 1 in the HashSet. Next, we will go to 3. Now, we will check whether 3 is present in the HashSet or not. We can see 3 is not present in the HashSet, so we will again add 3 to the HashSet. Next, we have 5. We will check whether 5 is present in the HashSet or not. 5 is not present in the HashSet, so we will add 5 to the HashSet. Next, we have 3. We will check whether 3 is present in the HashSet or not. Now, we can see the 3 is present in the HashSet, so we will simply return true. The time complexity for this approach is big O of n, which is much faster than the brute force solution we have previously. Next, we will start with our coding part. So let us start with our coding part. At first, we will declare a mutable variable. Let's call it as a set, and we initialize that with a HashSet. In Rust, to use a HashSet, we need to import that from standard collection library. So let us import that. Next, inside our function, we will start with the for loop. Now for each element of the nonce vector, we will check whether that element is present in the HashSet or not. In Rust, we can simply use the insert method. The insert method will try to add the value to the set and returns a boolean. It will return true if the value was successfully inserted in the HashSet and return false if it is already present in the HashSet. So in our code, we can simply write if not set dot insert num. So if set.insert return false, that means a duplicate has been found and we can simply return true. And if the loop finishes without finding any duplicate, we can simply return false. So let us now try to run this code. Our code has been successfully executed and we pass all the 3 test cases. Now let us try to submit this code. So we have successfully submitted this code and the runtime for this is 8 milliseconds, which is good.